Every day, millions of invisible, entirely subjective human desires drive the global economy. To understand how markets actually function, economists face a massive challenge. They have to figure out how to mathematically quantify abstract human satisfaction. The foundational tool for this is a concept called utility. In strict economic terms, utility is simply the capacity of a good or service to satisfy a human want. Crucially, this concept operates with complete moral detachment. Economic utility ignores ethics, long-term well-being, or societal benefit. It only cares if a craving exists and if a product satisfies it. A life-saving medicine obviously possesses utility. It fulfills a patient's immediate biological need to heal and survive. However, a narcotic or a liquor possesses the exact same economic utility if it satisfies a consumer's physical or psychological craving. As long as a human want is fulfilled by the transaction, regardless of the physical damage or moral consequence that follows, the good has utility in the eyes of an economist. Economics measures a good's raw capacity to satisfy, not its ethical worth. This objective detachment forms the strict groundwork for all market analysis. Defining utility as a concept is straightforward. The actual mechanical challenge lies in measuring it. To solve this, early economists introduced cardinal utility, the assumption that psychological states of satisfaction can be translated directly into discrete numerical values. They created a theoretical unit of measurement called utils. By counting utils, economists attempt to tally human satisfaction the same way a physicist measures joules of energy. Assigning hard integers to fluid human emotions is an inherently strange premise. Joy and satiation do not neatly convert into base 10 mathematics. But without cardinal utility, the math stops entirely. We require a standardized metric to build the formulas that predict consumer behavior at scale. Our objective is to take these subjective units of satisfaction, map them onto a graph, and figure out exactly how much uncaptured financial value a consumer extracts from a given market. Accepting the premise that satisfaction is countable allows us to convert the internal experience of desire into a functional geometric model. To test this theory, we will use a specific dataset, tracking the utils of a consumer sequentially eating oranges in a single sitting. We need to track two specific metrics. First is total utility, or TU. This is the cumulative sum of satisfaction derived from all the oranges consumed up to a given point. This split chart will track our consumer's satisfaction. The second metric, plotted on the bottom, is marginal utility, or MU. This isolates the rate of change, the specific, isolated amount of added satisfaction gained from consuming just one additional unit. Consuming the first orange yields 6 units of marginal utility, making total utility also exactly 6. Eating the second yields only 5 units of marginal utility. That 5 is added to our tally, pushing total utility up to 11. As the consumer eats the third, fourth, and fifth orange, a gap widens. As long as marginal utility stays positive, total utility climbs, but at a decaying rate. The critical inflection point arrives at the sixth orange, where the consumer receives exactly 0 marginal utility. The psychological reality of this coordinate is absolute equilibrium. The consumer is completely satiated and receives 0 joy and 0 utils from eating this specific orange. If forced to eat a 7th orange, the consumer is overfed. The action becomes actively detrimental. The marginal utility drops to -1, and for the first time, our total utility curve bends downward to 19. The absolute limit of our total satisfaction is entirely dictated by the continuous decay of our incremental desires. The pattern we just graphed forms a foundational behavioral axiom, the law of diminishing marginal utility. This law dictates that the consecutive consumption of identical units yields strictly decreasing incremental satisfaction. But this law is fragile. It only functions under 3 strict boundary conditions. First, the units of consumption must be appropriately sized and standardized. Giving a severely thirsty person a single drop of water will not decrease their thirst. It will aggravate it. Because the unit is too small, the marginal utility of the second drop will actually increase, breaking the law. Second, the consumption must happen in a continuous, short time frame. If our consumer eats a second orange 3 days after the first one, their appetite resets and the marginal utility remains high. Third, our economic model breaks completely when applied to goods that rely on network effects. A single telephone in a city has zero utility because there is no one to call. But as more people adopt the technology, the network grows. The marginal utility of each additional phone actually increases, completely defying the law of decay. The law of diminishing marginal utility holds true only in isolated, continuous consumption. Our theoretical models require precise, rigid boundaries to accurately reflect reality. Taking this abstract psychological data and weaponizing it for real market mechanics was the work of economist Alfred Marshall. This updated chart shows Marshall's leap. We replace the y-axis metric of utils with actual currency, giving us the demand price, the maximum money a consumer will surrender. Because psychological satisfaction decays consecutively, the cash they are willing to pay drops in exact tandem. The downward slope of the standard economic demand curve is simply a financial mirror reflecting the limits of human psychology. This transformation leads to Marshall's most powerful concept, consumer surplus. This is the mathematical difference between the absolute maximum a consumer is willing to pay and the market price they actually pay. This graph plots a consumer. Valuing the first unit highly, they'll pay $12, the second $10, and the third $8. The total demand price is $30. But markets clear at an objective market price, set here at $8. Buying 3 units costs $24. Subtracting that $24 cost from their $30 maximum willingness to pay leaves exactly a $6 consumer surplus. That $6 is the consumer surplus. It represents actual uncaptured welfare, a psychological profit that the consumer gets to quietly walk away with. For a seller, this consumer surplus represents money left on the table. If a monopolist identifies who values that first unit at $12, they can charge that person a higher price while selling to others at $8. This is price discrimination, an attempt to transform your psychological surplus into their corporate revenue. Taxation works on the same geometry. When a government adds a tax to a product, the market price rises, effectively shaving a layer off the bottom of the surplus triangle. The goal is to raise revenue while leaving enough surplus intact that the consumer still feels the transaction is worth making. Consumer surplus is the difference between what we value and what we spend. It is the core metric used to measure a population's actual welfare, making it the central point of contention for everyone from corporate strategists to tax authorities.